Okay, so let's look at the third question. Consider the following supply and demand equations for two interdependent commodities. So we have a big set of equations there, and we're asked to find, part A, find the equilibrium values for price and quantity. Now, unlike the last two questions were one set of supply and demand equations, but in this question we have two sets of supply and demand equations because we have two goods. So this QD1 and that QS1, that is one set of supply and demand equations. That's for the first good. But then we have the QDS2 and the QD2 and the QS2. That's the other set of supply and demand equations for the second good. So we're still going to take the same approach. We let QD equal to QS, but we're going to have to do it twice, once for each good. So let's just take the first good and say that we want to let the QD1, so we're doing, maybe I'll just label this part A. So I'm going to say let QD1 equal QS1. But I'm going to have to do it separately then for the next good. I'm going to say let QD2 equal QS2. Now, but as I said before, and let's call them all another letter. Let's just call this one. Now, I can't call them all Q, so I'm just going to call this Q1 and these pair Q2. Okay, so really what I'm going to do, there's QD1 and there's QS1, so I'm going to let these two expressions equal each other. Okay, so we'll just put them in underneath. For this QD1 I have 150 minus 3P1 plus 2P2, and I'm going to let that equal QS1, which is minus 20 plus 3P1. And I'm going to do the same for the other set of supply and demand equations. I'm going to let this QD2 equal QS2. So I have underneath 210 plus P1 minus P2 equals minus 15 plus 2P2. Okay, I'm going to have to clean them up separately. Okay, so let's just clean this first one. If I kind of draw, maybe I should draw a line there. Get, again, the same idea. Get all the, I have no squares here. You know, I just have letters in their own. I have one letter as one variable as P1 and another variable as P2. So I'm going to be going with simultaneous equations here, because if there's no squared, everything's fine. Go with simultaneous equations. That means numbers to one side. Letters to one side, numbers to the other. So what do I have? I have a P1 there. I'm going to take him over, and he's going to become altogether minus 6P1. That 2P2 stays as he is. And then I have that 150 is going to go back over there. I'm going to have minus 20. Go to the calculator to figure it out if you're stuck on it. Minus 20 minus 150. So I'll get minus 170 there. Minus 170. Same over here, get letters to one side, everybody else the other. There's a 2P2, that can go over there. So the P1 stays as he is. Nobody is there to add or subtract to him. The 2P2 comes over to become altogether minus 3P2 equals, now already it's a bit confusing, it's almost a bit annoying, this P1, P2, and even saying it minus 3P2. So what I'm going to give you a little tip in a second. You're allowed to rename them whatever you want, and I'm going to rename them X and Y, but I'm going to do that in a second. So I should continue a minute. So the minus 15 stays there, and there's a 210 is going to go over to meet him, and it's going to become minus 210. So altogether I'll have, and check it out in the calculator, minus 15 minus 210. It'll be minus 225. Okay. So now I have my two equations with two variables, and that's simultaneous equations. Now I'm going to give you a tip you don't have to do it if you don't want to, but it's just I find this P1, P2 business a bit annoying. So what I'm allowed to do it, I'm going to call, and maybe I'll just put that in a different colour, call P1, I'm going to call that X, and I'm going to call P2, I'm going to call that Y, call P2 Y. So there's no big deal about that. And what's going to happen, I'm going to get a value for x and y. But if I get pretend I get x equal to 1, then that's the same thing as p1 equals 1. And if say I get y equals 24, that's just going to be the same thing as p2 equals 24. So I'm going to call them, just to make life a bit easier, I'm going to call p1x, p2y, and I'm going to write, as I done before with the simultaneous equations, write one equation over the other. So what I'm going to get out of all of that is, again, you don't have to do it if you don't want to, but you're going to get the same answer anyway, but it just makes life a bit easier. So I'm going to end up with, I'm going to take this top equation here and take that fella down there. So I'll have minus 6x, I'll just go back to the blue, minus 6x plus 2y equals minus 170. And then I'll have x minus 3y. This is the second equation over here. I'm just replacing, I'm renaming them p's. Just, again, you don't have to, minus 225. Now I'm ready to attack these simultaneous equations. So let's do as we did before. Okay, look at the first column, and this always works. And what number, now I haven't it written there, but there is a 1 there, and nobody really bothers to write a 1. So I'm going to do a sort of switch, multiply the bottom number by the top equation, and the top number by across the bottom equation. So I'm going to have two arrows coming out, top equation multiplied by 1, and bottom equation multiply it by 6. Now, never mind, we'll not worry too much about the sign, the minus 6 there. I just want the numbers to be the same. If the signs aren't right, I can quickly change them as I did before by just flipping the signs across the equation. So really, multiplying the top equation by 1 means it doesn't change. So I'm going to be left with the same thing. Minus 6x plus 2y equals minus 170. And I'm multiplying the bottom equation by 6, so 6 by 1 is 6x. 6 by minus 3, just double check it in the calculator. 6 by minus 3, type it as you say it nearly, minus 18y. And I'm going to have that minus 225 by 6, let's just check that, minus 225 by 6, minus 1350, minus 1350. Now draw a line and double check, are you ready to, will things cancel, or do I need to change a sign? No, I'm fine here because I've minus 6 plus 6. Straight away they're going to cancel. So what I have then, I have 2 minus 18, 2 minus 18, minus 16y equals, and check then, minus 170, minus 1350. And I'll have minus 1520, minus 1520. How do I solve it? What's the next step after that? Just take, minus 16 has been multiplied on that side, so to take it across you do the opposite, you divide by minus 16 on the other side. So no change in sign there, you do the opposite of what's happening on this before you've changed anything. So I'm going to have, and I can just go straight to the calculator, I have minus 1520, minus 1520, press the fraction button and divide that by the minus 16, and I get 95. Okay, now again, simultaneous equations, I found one letter. As soon as you find one letter, sub it into any of the original equations to find the other letter. So let's just, what were my original equations? These are what I started with, so just take any one of those. So what I'll do is I'll sub it in the bottom equation because it's kind of looking there ready at you. So we have x, and I'm going to take that because I'm subbing in the y, so just throw it to the other side, equals minus 225 plus 3y. Go to the calculator and sub that in. So I'm going to have minus 225. Whoops, every time I press minus, that's going to happen. So if you know you're about to press minus, and as the first thing, just clear the screen first. Minus 225 plus 3 times 95. And I get 60. That and that all that equals 60. Now remember, now I can stop renaming variables. If you didn't change P1 to X and P2 to Y, you would have just found P1 equals 60. But it's all the same thing, so P1 equals 60. And that's Y was the same thing as P2. Okay. Now, what I'm going to have to do now is go back to the very original equations and sub them into your QD1 and your QD2, if you want to put it like that. So I'm going to take down, let's just take down them equations again. I'm going to take them down there because I haven't a lot of space on my whiteboard. So remember what we said. We said let QD1, we said QD1 equals QS1, okay? And all of that equals Q1. Now, so them two expressions in the light blue equals each other. So I'm going to sub in P1 and P2 into, and it doesn't matter because they're equal to each other, you can sub it into any one of those expressions. So really the easiest to sub into would be that second one. And I'm going to show you another tip in the calculator as well. It's kind of the same as what I'd done before with the minus b formula. I'm going to use these pink buttons here that act as memory buttons. So I'm going to put in, we'll go back to our x and y again. Let's call P1x and P2y. So I'm going to put in P60 and for x, or P1, 60, store it into x, and 95, store that into y. Now, so this it makes it quick to sub in numbers, and it makes it quick also to double check is your answer correct. So the easiest thing to do is just sub the P1 in there to get a value for the Q's, the Q1. So I'll have minus 20 plus 3. Remember what I called P1? I called it X. So I need the alpha button to get that, X, and I get 160. Okay. Now, to double check if your answer is right, and this is why I'm using these memory buttons, because I don't want to really type a whole lot of other stuff in. Again, I got 160. I should get the exact same thing if I decided to sub P1 and P2 into the top equation instead. So let's just quickly do that. 150 minus 3 times P1, but I called that X, plus 2Y, and I get 160 in, and that verifies that the answer is correct. If you get a different answer, then there's a problem. Maybe just run back and check it. Now, when I say a different answer, I mean I got 240. If I got you see, when I play around with decimal places, I might get 159.9. I can take that as the same answer, but we'll not worry about that just now at the minute. Now, I need Q2. So as I said, I let QD2 equals QS2, and I called the whole thing Q2. Now I can sub P1 and P2 into either one of those purple expressions. So let's take the bottom one, it'll be slightly quicker. Minus 15 plus 2 times, remember I called P2 Y, I called P2, I called it Y, and I get 175. If you have time, if you have no time in exam, just carry on. You know, you haven't time for this maybe in an exam. You have plenty of time outside an exam. So I'll just double check by subbing it into the top purple equation, plus X minus the Y, P1 plus P1 minus P2, and that was 175. And that's a confirmation that I have my answers correct. Okay, and just don't be afraid always to give a nice final answer. So the equilibrium values, just so we know that you're finished the question, remember we had P1 equals 60, P2 equals 95, Q1 equals that 160, and Q2 equals 175. Okay, let's look at the next part of the question, part B. I have, are the goods complementary or substitutable? So I'm just going to copy that down now to a new space in the whiteboard. I might copy the whole question down, I might need it. Now we have, are the goods complementary or substitutable? Now let's just look at what the notes say. So if I find the notes in the area in the notes where this comes up, I have substitutable goods. This is when the demand for each good rises if the price of the other good rises. And complementary goods are when the demand for each good drops if the price of the other good rises. So what am I looking out for here? So it's all about the demand. What happens the demand? We want to know what happened for each good. What happens the demand when the price of the other good rises? We want to know what happens then. So let's just take good 1 first, okay? So we have the demand for good 1. Let's just take it as this equation here. There's the demand for good 1. Now I know I have a lot of writing done over it. So the demand for good 1, I just write it a bit bigger here. We have QD1 equals 150 minus 3P1 plus 2P2. Now I only want to know what happens this is for good 1. I only want to know what happens this equation when the price of the other good, the P2, changes. So the only term in this equation I am concerned with is this term here. I don't care about these terms here. I don't care about them because I only want to know what happens as P2 changes. So I can literally just ignore that there. I don't need to know that box, what's in that box. I don't care about it because all I care about, what happens this demand, this value here, QD1, as the price of the other good, P2, changes. Now, if you think about it, just by looking at it and completely ignoring that part there, what happens as P2 goes up? Even test it, say it out to yourself. Well, if it was 0, I would just get this Q equals 0. If it was 1, I would get Q equals 2. If it was 2, I would get Q equals 4. If it was 3, I would get Q equals 6. 2 by 3 is 6. So it boils down to the sign there. That plus there. That means whatever P is, if P goes up, you're adding it on. So the overall effect would be that this goes up. So the plus means increasing as P2 and goes up. And I just increases. And I just draw it. I'll say that like as it. I'll put an arrow up. So overall, we can say that QD1 increases, I'll say increases it like that there, but to draw an up arrow as P2 increases, okay? If it was a minus, I would say decreases, because as P2 would get bigger, I'm taking off a bigger number all the time from this Q over in the left hand side. So the overall effect, it would be decreasing that stage. So really it boils down to if it's a plus, it's increasing, and if it's a minus, it's decreasing. Right, let's look at the second good. So what do I have? QD2, is that there? Again, I've scrabbled with all these values over it. So I'll just take it down there and write it a bit bigger. So I have QD2 equals 210 plus P1 minus P2. Now this is for good 2, so I'm only concerned with what the price of the other good does. Now I'm only concerned with that term. So what I'm going to do is I'm going to quickly rewrite that. I'm going to almost throw what I don't need into a bin, okay? So I'm going to draw, here's my bin here. I'm going to throw all the terms I don't need. I don't care about that 210, and I don't care about that P2, that minus P2. Throw that in there and say scrap it. Don't need to know about it. And all I care about is the plus P1. Now again, just really go to town on it. Don't care about that. Whatever's in that bin, I do not care about it. I just want to know what happens to Q on the left hand side as this changes. Now, as we see, it's the same idea. If P1 grows, if it gets bigger, all I'm doing is adding on the P1 all the time. And again, it's just about that sign, the plus there. So that means if P1 grows, I'm adding on P1 all the time. So it just has the effect that the Q gets bigger and bigger. And think about it, if pretend there was a minus there, if there was a minus there, you would say, well, sure, as P1 gets bigger, I'm subtracting this bigger and bigger value all the time. That would mean the effect on Q would be that it's getting smaller, it's decreasing. So we have a plus, and that means that we don't need to pretend anymore. We have a plus. That means QD2 is increasing as the price of the demand for good 2 goes up as the price of the other good goes up. Now, I have a little saying to help us remember that there about see how everything is going up. QD1 goes up, the demand for good 1 goes up as the price of good 2 goes up, and the same over here for this one. We have everything is going up, and my saying is Suez. Think of up. What's the Irish for up? It's Suez. And think of that S. That hint, there's a hint there that that's substitutable. So the goods are substitutable. Again, just a quick look over at the notes. Substitutable goods is when the demand for each good rises or increases or goes up if the price of the other good rises or increases or goes up. So that's the situation we have over in our question.